Well, we have another question here, question 6. The question says a given f of x equal to negative x plus 3 and g of x is equal to log of x base 2. Now, question 6.1 says on the same set of axes, sketch the graph of f and g clearly showing all intercepts with the axis. Well, we do know that we can write here 6.1. We have like f of x, which is given by negative x plus 3. And then this is a straight line. Okay, this is a straight line. And now g of x given by log of x base 2 is just a curve. Curve of a logarithm of a log function. Now, if I need to draw the two on the same set of axes, first we need to determine as the question says, clearly showing all intercepts, and then with the axis. So let's first find the intercept. On the right here. Okay, x int means that we're gonna make y equal to 0. Okay, if I do f of x, okay, f of x, we said f of x is just the value of y. So I'm gonna say y equal to negative x plus 3. So I'm gonna make y equal to 0 and then solve for x. So y is 0, and then like 0 equal to negative x plus 3. So if I move the negative x over, we have like x is equal to 3. So this is the x intercept. Okay, and then for the logs, we have like y equal to log of x base 2. We say that x intercept will make y equal to 0, and then that makes log of x base 2. But now this means what? 2, according to the log definition, this means 2 to the power of 0 equal to x. Okay, because logs is like exponential, I'll say the inverse of an exponential function, and then it's just 1, and then x is 1. So let's say x is equal to 1. This is the x-intercept of the log function of g of x. Now, y-int is usually the easier one to calculate. Y-int means that it means that we're going to make x is equal to 0. Now, over here, I'm going to say, because y equal to negative x plus 3, I'm going to make x is equal to 0. We sub in the value of x, which is 0, there, and then we got like y equal to 3. Got the y-intercept. And then for the other function, the log, we have like y equal to log of x base 2. So now this will mean y equal to log of 0. The logs function doesn't accept 0 as input. Okay, 0 can be the output, like over here, the outputs, the y value 0, but the input x cannot be 0. So over here we cannot sub in 0. So therefore there is no y-int, no y-intercept. Now that we have the point, we have the intercept, we can draw the graph. I'm gonna move my board over here. I'm gonna use the information that I have here to draw the graph. Now we can just start by drawing the x-axis. Draw the horizontal line, the x-axis, and then we can draw the y-axis. Must be perpendicular. They must be perpendicular. Okay, draw it over here. Et voilà. Now, I know that this one is a straight line. The first graph, f of x is a straight line, and then we have the intercept by 3 and 3 there also. So count here 3 units. Let's say 1, 2, let's say, okay, this is 1, let's say 2, and then 3 there, and then same also here. If I move this a little bit down, okay, so we have like 1, 2, and then 3 over there. So my graph must cut, it must be okay, my straight line must connect 2 points. Approximate, yes. So let's say the orange line is the, okay, I need to let's say this, so this blue line is the line of f of x, okay, and then I call, is that blue or I don't know, I'm not that good in color. Let's say this is blue. Now now we need to draw the graph of the logs. Okay, for this I cannot, the log is a curve, so I cannot use the ruler to draw the log. And then I guess you want I'm gonna use free hands to draw the graph. So I can see that it has an x-intercept by 1 over here. So my 1 is there, it passes through there, okay, and then it will go up. So now, and then another property is that log function has asymptotes, okay, over here, meaning it has a vertical asymptote on the y-axis. So my graph may be something like, may look something like this. It's a curve. I'm gonna go down like that's endless, like this. Yes. Well, that's trying to be accurate. I hope you pardon me. I mean, closer to accurate. So that's what I'm trying. Okay, anyway, we don't need to draw something perfect here. Okay, let's say this, we have f of x. Okay, that f of x, and that g of x. And then asymptotes here by 3 and 3. And then here also it's by 1. Now, this is the graph. The following question is, that was 6.1. And now 6.2 says what? Write down the equation of g minus 1 of x, the inverse of g in the form y equal to. Okay. And I write here 6.2. We're looking for g minus 1, the inverse of g. Well, we do know that g is, okay, g of x first, g of x was equal to, is given by log of x base 2, okay? So we call g of x y, that's log of x base 2. But if I need to find the inverse, it is when we substitute the value x by y, we interchange, we swap the variables. Okay, we're gonna call x, y, and y x. So this is x, and that's y. So it's gonna be like x equal to log of y base 2. Now we're going to make y subject of the formula. It means according to the log definition, the log definition says this: if you have like x equal to log of a base b, this implies that b to the power of x equal to a. Yes, b to the power of x is equal to a. So this is the same thing we're going to apply over here. This means that's 2 to the power of this 2. okay, b to the power of x, so 2 to the power of x equal to y, b to the power of x equal to a. So this will be 2 to the power of x equal to log of y. And then, excuse me, not log of y, but just y. 2 to the power of x equal to y. Therefore, the inverse will be 2 to the power of x. I'm going to say, therefore, g minus 1 of x is just 2 to the power of x. So you can write either this one or this one, see the same thing. Okay. The next question is 6.3. 6.3 says, explain how you will see question 6.1 and or question 6.2 to solve equation log of 3 minus x base 2 equal to x. Okay, let's read it again. Explain how you will use question 6.1 or 6.2 to solve the equation log of 3 minus x base 2 equal to x. Quite interesting. Let's see. I want to move my board over here. Okay. I don't need too much space like that. So this one, I can just move it, okay? I can just move it over here. Move it there because I need a space. So then my error is reverted, not this one. So 6.3. Now it is given that a log of they say that we need to explain how we're gonna do log of 3 minus x, okay, base 2 equal to x. Oof. Explain how we can use 6.1 or 6.2 to solve this. Now you have like log of 3 minus x base 2 equal to x. Okay, if we apply this property of logs, you want to move it over here. Let me move it again. I want to move it again. If I apply this property, this will mean that 2 to the power of x. So this means that 2 to the power of x okay, will be equal to 3 minus x. If I apply this property, because it's going to be 2 to the power of x equal to that one. So see, b to the power of x equal to a. So 2 the base to the power of x equal to 3 minus x. And then this is this is the same thing as 2 to the power of x equal to negative x plus 3. Oh, now if I remember, this was f of x, right? This was f of x. If you check, let's check. F of x is negative x plus 3. So we can also use that. Okay. Then how can we say about what can we say then about log of 3 minus x base 2? So about the inverse function, what we know that the inverse function is the reflection of one function above the line of the line y equal x. So this is just like, okay, this is just like y, and then y equal x. So that's the line. So now when we reflect, okay, this, because remember we got g minus 1 equal to 2 to the power of x. This is that. So it is actually the reflection of the graph of G about the line y equal x to obtain G minus 1, and then also determine the point of intersection of f and G minus 1. So this intersection, this is f. Oops. This is G minus 1, and that was f of x. So that's how we can explain it. Yes, and then the following question is, let's see, 6.6. Now the question says 6.4. Write down the solution of log of 3 minus x base 2 equal to x. Right. Okay, let's see. For only 1 mark. Wow, interesting. Okay, we have here 2 to the power of x is equal to 3 minus x. Well, what can we do? Let me write it over here. So we have like 6.4. We want 2 to the x equal to the solution of this. Well, I can see, I can immediately see that over here the solution is, I don't see how I can calculate it, but it's easier to see that x has the value of 1, because if x is equal to 1, you have 2, and then if it's 1, you also have 2. So this is the only possibility to have this. So, and then it's just 1 mark question. So it means the calculation were not really involved. You just look at the question and then see that the answer here, x must be equal to 1. So, thank you. So when I say look at the question, I mean you're going to use intuition here. Intuition to see that x has the value of 1. Thank you.